Okay, in this problem we have a rain gutter which is formed by bending up the sides of a rectangular sheet of metal. Okay, so this little side that we're bending up is X, and so up it comes. So if we originally had a 56-inch wide rectangular sheet, then this right in here would be 56 minus, let's see if I can write it, 56 minus both sides, so minus 2x. Okay, and then the height here is x. So the function that represents area, we would do length or width times, let's see, we want area, the cross-sectional area of the gutter. So we want to have a function here that represents this cross-sectional area of the gutter. And that would be length times width, or base times height, however you want to label it. So it would be x times 56 minus 2x. So we would have 56x minus 2x squared. That's the first part. So find a function that models the cross-sectional area of the gutter. And the second part, okay, the next thing we want to do is maximize that area. So let's find the x value that maximizes that. What we're being asked to do is find the vertex. Okay, so let's see, I'm going to write this in descending order. So negative 2x squared plus 56x. And you could say it is y, or you could still have that as area of x, which is fine, right? But what we're going to do is find the vertex. So the vertex is formed by saying, let's see, negative b over 2a. Negative b over 2a. All right, and a is negative 2, and b is 56. So we would say negative 56 all over 2 times a, which is negative 2. And so that would give us negative 56 over negative 4, and that is 14. All right, and now the very last thing is we want to find what is the maximum area. Okay, so that would be our output. So we're going to put the number we just found for x, that 14, we're going to plug that into our function. So we'd get negative 2 times 14 squared plus 56 times 14, and that gives us a maximum area of 392. So with the height of the gutter is 14 inches, then we reach our maximum cross-sectional area of 392 square inches.